Every point in the sky can be localized by two numbers, or coordinate. Just like on the Earth, every location can be identified by two coordinates. The Earth is approximately spherical, and the points in the sky are described as a projection of the Earth reference system. On a spherical surface, the distance between 2 points is an arc of a circumference. The sphere is mapped with a series of circumferences, horizontal and vertical ones, and each point is identified with the length of the arc, or angular distance, of the circumference passing between the point and a reference circumference. On the Earth, we define the equator as the circumference with the largest diameter, and the reference circumference to define the latitude. The horizontal circumferences are called parallels. The vertical circumferences are called meridians, and they all have the same diameter. All meridians pass through the north and the south poles. Conventionally, the main meridian, used to define the longitude, is the circumference passing through the English town of Greenwich. The latitude of a point is defined as the length of the arc of meridian passing through the point and the intersection of the meridian with the equator. It can be northern or southern. The longitude is the length of the arc of the parallel passing through the point and the intersection of the parallel with the main meridian. It can be eastern or western. When talking about the sky, we have two types of coordinate systems that we can employ: the azimuthal and equatorial coordinates. In the azimuthal system, the spherical grid is placed like a dome over the observer. The celestial meridians all meet over the head of the observer at the zenith, and below their feet at the nadir. The azimuthal coordinates, azimuth and altitude, depend on the position of the observer on the Earth. Therefore, they are not the same from different points of the Earth. The azimuth is the length of the arc of the horizon between the geographical north and the celestial meridian passing through the object, measured in a clockwise direction. It can go from 0 to 360 degrees. The geographical north is found with a compass and correcting the azimuth of the magnetic north by the inclination of the Earth axis. The altitude is the length of the arc of the celestial meridian passing through the object measured above the horizon. It can go from 0 to 90 degrees. Negative values are below the horizon and therefore not visible. The equatorial coordinates are a direct projection of the Earth coordinate system on the sky. The celestial meridians cross at the celestial north and south poles, and the celestial parallels appear inclined of an angle equal to the Earth inclination axis. The sky grid changes from place to place, but the coordinates, the right ascension and declination, are equal from every point on the Earth's surface. The celestial equator is the projection of the Earth equator in the sky, and it corresponds to declination 0. The right ascension is the angular distance on the celestial equator between the object and a reference point, the vernal point or first point of Aries, that is, the location of the Sun at the spring equinox in March. It's measured in hours, minutes and seconds, from 0 to 24 hours. The declination is the angular distance on the celestial meridian between the object and the celestial equator. It is measured in degrees, primes and seconds, from 0 to 90 degrees, positive above the celestial equator and negative below it. It is possible to pass from the azimuthal to the equatorial coordinates only with the knowledge of the latitude of the observer. While the azimuthal system depends on the latitude of the observer, the equatorial system depends on the inclination of the Earth axis. The inclination angle varies slowly with time due to the lunisolar precession of the Earth axis, completing a cycle in about 26,000 years. All the equatorial coordinates are therefore referred to a specific moment in time called epoch. The currently used one is the J2000, meaning the midday of January 1st, 2000 of the Gregorian calendar. Another type of celestial coordinates is the galactic coordinate system. In this system, the Sun is at the center of the projected sphere, and the galactic center is used as a reference point. The galactic longitude is the angular distance on the galactic plane between the object and the galactic center, anticlockwise. It's measured in degrees between 0 and 360 degrees. The galactic latitude is the angular distance above the galactic plane of the object. It's measured in degrees, from 0 to 90 degrees, with positive values above the galactic plane and negative values below it.